All right. Good morning, good afternoon, good evening, folks. Thanks again for joining us for this machine learning community stand-up. And if you are new, welcome to the stream on the machine learning community stand-up. We typically talk about all topics related to machine learning, as well as how that intersects with .NET. I'm your host, Luis, and if you had joined us before, you might notice that some of my co-hosts are currently missing. Unfortunately, Bree won't be able to join us, and Jake might be able to join us a little bit later. But with me, I have Cassie here, who's going to talk to us a little bit about PyTorch and ONNX. Cassie, would you like to introduce yourself?
Yeah, hi, I am Cassie Breviu, and I am a senior program manager at Microsoft on the ONNX runtime team. And so I'm super excited to be here today to talk to the ML.NET community. .NET was what I did before I kind of transitioned into AI and machine learning. So I love C#, I love .NET. And so I'm really excited to kind of talk to you about my journey and get you started with maybe using PyTorch and ONNX runtime. And I'm sorry if I scared your co-hosts away. They're like, oh, Cassie's here? Like, can't come to this one.
No, not at all. Not at all. They'll be able to make it maybe. But Bree will definitely, unfortunately, she won't be able to join us. But anyway, we're still happy to have folks joining us here and to have you talk to us a little bit about PyTorch and ONNX. On the last stream, we actually had a PyTorch related topic, which was Torch Sharp. For folks who may not be familiar, that is a set of a library that provides .NET bindings for the libtorch library, which is kind of what powers libraries like PyTorch. All right, so make sure to check that last stream out if you're interested in seeing how you might use some of the concepts that we're going to talk about today from within sort of like a .NET sort of environment. So yeah. But before we get into the stream, let's do the segment. I don't think we have a name for this yet. We've only tried it like a few times, but essentially it's just going over the machine learning glossary. So today's stream is brought to you by the letter D. And the word that we're going to be talking about is dropout, which actually relates to some of the topics that we talked about last time. The word was cross-validation. And essentially cross-validation is a technique to prevent overfitting. So if you're not familiar with overfitting, that essentially kind of means that your model learns the data a little bit too well, right? And it doesn't perform well on new data that you give it for testing. So dropout is similar to cross-validation, except it's a little bit more explicit to neural networks, which is kind of what we're going to be talking about today. So dropout is a technique to regularize your networks and prevent overfitting of neural networks. I have let me see here. I have kind of a visual here. I was hoping I could find a really cool like GIF that you could that could show you in real time sort of how it happens. But the idea is traditional neural networks, you have many nodes that are just interconnected here. And with dropout, you'll see that some of the nodes, as the name sort of implies, drop out, or you don't use them as part of a portion of your training. And as a result, hopefully, your model or your network doesn't learn your data too well, and you're able to generalize and work better with test data. So that's dropout. Let's see here. Now let's move on to our community links, which, yeah. Did you have anything, Cassie?
Overfitting was like one of the first like rookie mistakes I made when I was teaching myself. And I trained my model and I was like, I'm getting 100% accuracy. This is amazing. Like, I'm so good. And then I deployed it and started like testing it with real data, and it was doing terrible. And I was like, what did I do wrong? Like, what is happening? Like, my training said it was 100. So I always tell people when you get started, like if you get 100% accuracy, like it's probably overfitted, like you should be suspicious. And then, so I do that. And with dropout, I always think of like neuroscience, like of the actual brain and how they're like forgetting things is actually a feature of your brain. Like you need to be able to forget things for like proper brain function. And so it's interesting that with neural networks, it's the same thing.
Yeah, absolutely. I mean, I think an example that I really like how I've heard it expressed is, kind of like if you were to study for a test and you had the questions and the answers and you just memorized all the answers, like you are probably going to pass that test, right? But it's not because you actually learned anything or the concepts related to the questions, is because you learned the answers, right? So you can think of overfitting kind of like that. So with dropout, cross-validation, right, these are things that can help you solve that problem if you do end up running into it.
Awesome.
Yeah, let's see. Okay, so let's move on over to community links now. So the community links, you can find them. There's the link right there. So you go to the urls.com and go to MLNet, Standup, and Today's State. So we have a lot of really interesting sort of projects and presentations that folks are doing from within the community. One of them actually happened this past Monday. So we had Luis Beltran, who I don't think we had him on the show, but he's sort of part of the ML.NET community and has done a lot of work with ML.NET and just .NET in general and AI. So in this case, Luis talked about how to build serverless machine learning solutions, right? So this is like super like Inception. So, I was the host and then Luis was the guest, and he talked about how you can use tools and services like Lewis.ai to build chatbots and hook them up via serverless functions, so Azure Functions, to services like Twilio and WhatsApp and all sort of different chat applications for analyzing text and performing tasks autonomously on behalf of users. All right. So if you're interested in checking that out, go on over to this link here. Let's see. Something else that we have here from Daniel is how you can build a sentiment analysis application with ML.NET and then deploy it as part of an ASP.NET web app. So this may be a pretty common scenario that you've seen. Daniel does a really nice job of walking you through the steps for creating that sentiment analysis model using Model Builder. But then, and maybe you've seen these types of applications deployed to ASP.NET, applications, or these types of models deployed to ASP.NET applications. But in this case, something that Daniel does a little bit different is he uses .vvm, right, for his ASP.NET application. So if you're using .vvm and ASP.NET and you'd like to deploy your models that way, make sure to give this tutorial a look.
You can do so much with Model Builder and AutoML. These are awesome.
You can. Yeah, I mean, it's actually nice that you mentioned that because we do have AutoML in this case. And again, using Model Builder and AutoML. And in this case, Miodrag, which I hope I got your name right, I apologize if I didn't, uses it to basically train a model to help with lead generation and just making sure that as you get leads in, say, some sort of sales funnel and you're looking at who converts and who doesn't, they use AutoML and Model Builder to be a little bit smarter about that process and not just follow every lead, but be a little bit more, a little bit more informed and data driven in terms of how they follow up on those leads. So if that's something or use case that you're interested in, make sure to check this out. Let's see here. Another tutorial that we have here, John Wood, who you may know from his YouTube videos and all the really great work he does with the community. We have this tutorial that was just published, which shows you how to train an image classification model using Azure. So if you're not familiar with Model Builder and some of the models that you can train, you can do image classification and train image classification models. You can do that locally, both on CPU and GPU. But if you need a little bit more compute, you might be able to leverage Azure, right, and the Azure compute. So this tutorial just walks you through that whole process, how you can use Azure to train your image classification models. Speaking of image classification, Mental Stack here went ahead and created a sample of how you can use ONNX runtime, which we're going to hear a little bit more about later, to score or make predictions with and perform object detection with the YOLO v5 model. If you're not familiar with YOLO, it's a fairly commonly used deep learning model or deep learning architecture for doing object detection, right? So in this case, Mental Stack takes that model and uses the ONNX runtime and .NET to basically create these bounding boxes that you see here. So if that's something that you're interested in seeing, make sure to check that out. Let's see. So those are tutorials. In terms of events, we actually have a lot of stuff that's going on from within .NET. We got some videos coming out later this month that are going to kind of walk you through the sort of the 101 of ML.NET and how you can do machine learning in .NET. We also have this other event happening, which is the Let's Learn.NET, focused on machine learning. And throughout this event, there's going to be a lot of things that are going to be happening, one of which is going to be going through a Learn module, which is actually in the works, and it will be coming out later this month as well. So stay tuned for that. There's a lot of really exciting things happening in terms of the .NET ecosystem. One of which you might have noticed is you can now use notebooks. There's a notebook editor inside of Visual Studio. So if you may be familiar with Jupyter Notebooks, this is maybe you've used the .NET Interactive Notebooks inside of Visual Studio Code. That similar sort of tooling and experience is now inside of Visual Studio in preview form. I'll let Jake. Jake, would you like to say a few words on this?
Sure. So yeah, we just released it. We actually, this post is already outdated. We recently added a rich markdown experience and a rich code editing experience. So you'll actually get IntelliSense, you'll get syntax highlighting, you'll get the markdown viewing experience you would expect inside of a notebook. So if you're already familiar with notebooks, go use them. Now you'll be able to use .NET and generate graphs and all the stuff you need to analyze your models. If you're not familiar, in this blog post, there's it'll show you how from Model Builder you can actually generate a notebook so that you can start to become familiar with notebooks. So when you have the extension installed, the notebook extension installed, you'll see in Model Builder this extra thing on the consume page where it'll generate a notebook. And that notebook will have in it the code to consume your model, to train your model, and it'll also start to introduce you to things like PFI, so you can understand, which features actually contribute to the output of your model and stuff like that. So we're gonna keep trying to leverage this in the future. We'll keep putting new things in the notebook that we generate. Again, that notebook is for your model. So everything that you chose in Model Builder, we then leverage that in the notebook. So it's code purposefully written or specially written just for you. Once you generate it, and you can see how your model works.
I'm going to show a little bit about notebooks as well. So I'll give an intro today to notebooks and some tooling like that, like what Jupyter notebooks are and how to use them. So stick around for that so you can learn. And it's really cool. I think it's a really cool way to learn when you go from like Model Builder, where you're using a UI to build something, to code, because you can reverse engineer what's happening, and then it helps you kind of on your journey. Like that's kind of how I started, which I can talk a little bit about if you want. But like basically I started with a low code or no code UI, like Azure Machine Learning Designer is actually where I started. And then I reverse engineered it. And from there, I started learning how to do Python, and then went into classical machine learning and then deep learning. So that's a really cool way to get started into like kind of do that top down type of learning, where you start with the big picture and like a UI, and then get down into the notebooks and what's actually the code is doing.
Yeah, that is so true. And just to kind of call out, right, it's part of Visual Studio. And although you can definitely, generate the notebook here for machine learning purposes, notebooks themselves, they're not only for machine learning, right? So let's say you were working with a customer in support, right, and you were trying to reproduce or show how a certain bug or error came about. You can just use a notebook and replay through those steps, right, to sort of recreate that scenario. So there's tons of uses beyond machine learning. It just so happens that machine learning is one of the sort of the areas where you see a lot more of it.
Yeah, my long-term dream is that every Wikipedia page or whatever or MD file you see on GitHub that shows you how to use an API and gives you some examples, instead of that, you can just download download the notebook file and actually run the code cells and go from there, instead of having these code snippets you have to copy and paste.
Yeah, it's so good for tutorials. Like I love it for tutorials because you have the markdown examples, and then you actually get to literally run it.
Yeah, I mean, I think you may have worked on prototype that feature inside of Microsoft Learn, I believe, right? Your PyTorch modules. Yeah.
So one of the learning paths that I'm going to show you that I co-authored with some amazing, brilliant people. We also got the first learning path that has interactive notebooks on Microsoft Learn. So if you don't have Jupyter notebooks and you don't know how to configure Python local environments and all that stuff, you can actually just jump into it through the web UI, through Learn, and run a notebook. To kind of get comfortable with how they work, which is nice too when you're starting a new topic, because you got to go and like install everything and get everything configured. Although with like code spaces, now that's even becoming easier to like not have to do all that. But generally when you start anything, right, you have to go install the tools and packages and all of the different libraries you need. And it's really nice with Microsoft Learn that you can just go into something and it's all ready to go.
Yeah, for sure. Yeah, that's a huge thing as well, right? Like reproducing that environment and all that. So yeah, I mean, if you're interested, again, if you've tried the .NET version of it, with VS Code, and if you prefer to be inside of the Visual Studio experience, right, and that's where you do your development, definitely check it out. And there's instructions here on how you can go about creating that. There's a few improvements that took place in terms of consumption code and making that a little bit more approachable and easier to work with, as well as in terms of performance, making it perform better than the previous version. So make sure to take a look at that. There's sort of a status update on addressing the different pain points based on the survey that was sort of filled out a few months ago. Just a quick update on what's going on there. Let's see. There's this other thing that I'd like to kind of point out here, which is the roadmap here for ML.NET. There's a lot of really interesting sort of pieces of information here that you might be interested in. One of which might be the deep learning story. We're going to talk about deep learning in general here, but part of that story, as I mentioned earlier, we talked about it on the last stream, is Torch Sharp, right? And being able to create custom neural networks. You can currently train some deep learning models with ML.NET, and there's other libraries like TensorFlow.net and Torch Sharp that allow you to do that, but making sure that it's easy and accessible is definitely a big part of that. In addition to very, very close integration with the ONNX runtime, making sure that that experience is a little bit better when consuming deep learning models, right? A few other things. There's a few scenarios coming to plan for ML.NET. So name density recognition, that's a really, really big one. This other one, I think it's a pretty commonly asked one, which is not how can you make predictions or how can you use models without having to create input and output schemas, right? So potentially a dynamic data view could help you with that, as well as time series forecasting and a few other things here, like model explainability and responsible AI. So make sure to give us a look. It's over in the .NET Machine Learning repo. So take a look, provide feedback, and let us know. What are some things from here that you would that you like, and maybe some that you think we should take a look at. And last but not least, speaking of feedback, you can go over to this. Let me see. Pull up the banner here. aka.ms/mlnet stand-up feedback. So we've been doing these for over a year now. We forgot to celebrate the 1 year, which was I think back in August. But other than the chat, right, there's not really a way for us to communicate with you. So if you'd like to let us know what's working, what's not working, go on and go to this form here and provide some feedback in terms of what are things that you would like to see, what's working for you, what's not working for you, what are topics that you'd like to see, as well as if you're interested in joining us for one of these and be a guest, by all means, definitely leave your information and we'd be happy to chat with you and have you on. So with that, I know I went way over there, but I know you don't really come to fill out forms. You really came to learn about PyTorch and ONNX. So with that, I'm going to turn it over to Cassie.
Awesome. Thank you. It's so good to know what's going on in the community, though. There's a lot of things in there that I wasn't aware of, and it's cool to see. Like, I didn't know notebook support was happening in Visual Studio. Like, that's awesome.
Yep.
I knew it was in VS Code, which I'm going to show, but I did not know that was there. And there's a lot of good things. The ethical and responsible AI stuff in ML.NET. So frequently, the ethical side seems to come after machine learning models are built. And it really should be the first thing you think about. You should think about, should I build this model before you even start building it? And what are like the ethical and like consequences of doing this? Like what are the problems that could happen within society, or with what could you do with harm with that model? And so I feel like there's so many scenarios, and you can like even just Google with Bing and find different examples of really bad things that have happened from people that have put models in production, and like discrimination that has happened because of bias within their data. So I'm glad to see that's coming to ML.NET. And I really think your first thought when you're building a model is it even ethical to do this?
Totally. Yeah. And we had a stream, I think a few months back now, where we kind of focused on that. One of the interns over the summer Jessie, she did a really great job of sort of analyzing the space of responsibility and explainability and things like that. And there was a lot of really good work and insights that came out of that eventually, hopefully we'll make happen inside of ML.NET. So
fantastic. All right. So should I, is it go time?
Go for it. Floor is yours.
Cool. All right. So I'm excited to talk to you today about PyTorch and ONNX runtime. And we already know who I am and what I do, so I don't need to talk about that again. But like I said, my background is C# and .NET before this. And I think it's really interesting to kind of think about and learn about the ways that you have to kind of change the way you think a little bit when you start building machine learning models, because although it's still software development and you're still writing functions, you're writing functions with data. Is kind of how I like to explain it. So I'm talking a little bit about machine learning and how to think about building machine learning models and how you kind of change the way you think as you start building them. And then we'll jump into the good stuff of how to use PyTorch, the different libraries, and then how to use ONNX runtime. So when it comes to like the mind shift, oops, too far there. When I think about C# and I think about the development flow and all of the amazing tools that are in like Visual Studio, when I was like C# day to day, like if you think about all the extensions, like Visual Studio felt like an extension of me, like I did all my shortcuts and all these things, and I was very in my dev flow. But when I started Python or ML.NET wasn't a thing yet, and I wanted to learn how to do machine learning. So I had to switch to Python, and I was very resistant right away because I liked my C# world. But I will say now that I've learned both, like they're different tools and they're used for different things. And there's things that Python is amazing at, and there's things that C# are amazing at. So that's kind of one of the ways that you have to start thinking about it a little bit differently if you start going into the Python side of machine learning development. And the other thing about that is it's more of REPL. Like we talked a little bit about the notebooks and how they're like executable cells, which we'll see. So your debugging in your dev flow is different. The tools weren't originally there. So like all the IntelliSense and things that I loved in C# when I first started wasn't there, but now they are, which is awesome, including Google Colab. Like I have, or not Google Colab, GitHub Colab. I have actually installed in mine so I can use that with my notebooks in VS Code, which is really cool. So things have come a long way and there's a lot of tools out there. So when you start thinking about traditional programming versus machine learning, I really like this. And I'm actually going to make myself disappear so I'm not in the way. There we go. So on this particular one, we have traditional programming, which you're very familiar, right? You'll have your data, you write your algorithm and your static logic, and you have an output. With machine learning, you kind of change things around a bit. You have your data, which are like your features, and then you have your labels, which is your output. So this is your data that you're feeding into an algorithm, and this is specific to supervised machine learning. Out comes an algorithm or a model, and then you use that model by deploying it. And now that there's so many different tools and things like that, you actually can kind of stay in this like using the model side where he was showing you that YOLO model, where you have these pre-built models that you can grab and implement into your application. And with things like ONNX runtime, you can inference in C# with using those pre-built models. So there's so many different ways to go about this. But when you start thinking about building models from scratch and about how machine learning works, like this is kind of a mind shift that happens. So that basically means then instead of, I'll make myself appear, ta-da. And then instead of, you're finding and exploring patterns in data instead of humans writing code, you're supplying that data. So some of the different tools and libraries, and I should say I'm starting like kind of basic and intro, and we're going to go like really deep, really fast. So like we're going to go through a lot, but I want to kind of make sure everybody kind of understands what everything is before we jump in. And then, so with languages and libraries here, like we're going to be talking about PyTorch. You've probably heard about TensorFlow. I'm sure you've heard about scikit-learn, and you obviously have heard about ML.NET, which is right behind my head. There we go. And then we're going to talk about Jupyter Notebooks and then VS Code and Jupyter Notebooks. So you have different editors that you use to build your model. Okay, so let's get into PyTorch. So PyTorch is that open source machine learning library that you use to build models. There's 4 different libraries, and I'm going to open up this link here and show you their docs here so you can see. So within PyTorch, you have all of the building blocks that you need to make a good neural network. You have your neural network function to actually that you'll inherit when you create your class. You have data utilities that you need CUDA to access the CUDA GPU. So for running machine learning models, they are faster on GPU. And CUDA allows you to access the NVIDIA GPU execution provider. That's what it is. So you want to be able to use that for your large models. There are like simple models, and when you start out, that can run on CPU. But when you start getting into more complex, bigger models, you're going to want to use GPU. When you kind of go down here, there's another really important package in here, the data package, right? Can't do anything without data. So within that, we have our data sets and data loader, which I'm going to show you how to use that. So definitely make sure to leverage the docs when you get started too and read about the different functions that are in here. But that's the main PyTorch library. Now within, oh, why did this come? There we go. Within PyTorch, there are some other libraries that you have specific to different domains, like computer vision. So you have Torch Vision. So if you're going to be using Torch Vision, you're probably doing a computer vision model, and you're going to need different transforms that are going to help you prepare your data for processing. So for example, like resizing an image or image to tensor and those types of things, or also like popular data sets to get you started, open source data sets. Those are things that are going to be available within Torch Vision. If you go into Torch Audio, you're going to be doing things with audio data instead of images. And it's the same thing. You need different transforms. So you're going to be using with like waveforms and spectrograms, and you're going to need an audio backend like SOX or sound file, which is going to allow you to load those data. And then you're going to need to transform those data or that data into tensors in order to run them in your machine learning model. So as much as it is about building the model in the neural network, it's way more about the data, preparing the data, pre-processing it, and getting it ready. So, and then there's also Torch text, which is the same thing, but for natural language processing, right? So again, you're going to have different functions that you're going to need to pre-process text data. You're going to have to do word embedding and tokenization and all of those types of things that are going to prepare your data to be trained by a model. So PyTorch gives you all of these things out of the box to get started building, along with the open source data sets that you can easily load, which I'll show you in the demo. So I think a really good way to get started with PyTorch, I wish this tutorial existed when I started, but I was lucky enough to co-author it with brilliant people like Seth Juarez and Dmitry Shashkinov, Ari Bornstein, who's now at PyTorch Lightning. And this, oh, and then also Suraj Sabranim, who is a cloud, or is an advocate at PyTorch itself. So we actually collaborated with PyTorch to build this tutorial as well. And what it includes is 4 different modules. And the idea behind it is that anybody could kind of come in and get started, starting with the basics of machine learning. What are the basic concepts that you need to know about PyTorch and about machine learning in order to build models? And it's really cool the way that it's built, because it's kind of built where you can do a quick start where you get everything really quick, like, or you can go more of the deep dive. So like maybe I've used TensorFlow before and I'm familiar with machine learning or ML.NET, but I just want to know how to do it with PyTorch. Like you can do that with the quick start, or you can go step by step. Now that is the Learn the Basics part, which is also on pytorch.org. And you can also run it on Microsoft Learn with those interactive notebook experience that we were talking about. And then there's one on computer vision, natural language processing, and audio. So it covers all of those main domains. So this is what it looks like. And I'll jump in. You can get to it right from pytorch.org. It has those 4 modules. And I highly recommend starting here, particularly if you don't have your machine configured for AI development or machine learning development, because you can go right in and run in Microsoft Learn. It's so cool. Okay, so that was like high level of PyTorch. We'll jump more into those details once we get into the demo. But before we do that, I want to talk about ONNX runtime, or ORT for short, and kind of the awesome things within it. So there is a couple things with ONNX. So there's an ONNX model, which is the open format built to represent your model. And then there's ONNX runtime, which is the runtime to inference and train your model. So when I first started using ONNX, I honestly did not know that they were 2 different things. I thought ONNX and ONNX runtime were the same thing, but they're not. So just to be very clear, ONNX is the format of the model, and there are multiple runtimes you can use. ONNX runtime is one of them. I love ONNX runtime because you can do things like cross-platform deployment. You can inference in multiple languages, so you can build your model in Python, export to an ONNX model, and then inference in C#, JavaScript. There's even a React Native library, so web, all the good stuff.
To pause a little bit there, Cassie, have you had a chance to use Blazor? We have a question here from Sharafuddin, and Sharafuddin is asking, can I use an ONNX model in Blazor?
So I have not tried that, but Blazor is just WebAssembly. So it's C# compiled for the front end. And I know you can, I've never tried it, but I feel like in theory it would work. But
yeah, I think it works for, because there's 2 flavors, because there's a WebAssembly and there's the server version. I'm pretty sure the server version works, but WebAssembly, I'm still not sure as well. Yeah. So, yeah.
That's a good question. Because you can also with like, yeah, I would have to try that. So
awesome, thank you.
Like I said, in theory, I think it would, but it's something I would definitely have to test.
Awesome, thanks.
Mm-hmm. Okay, so then when it comes to converting your model, there's all these different libraries, right? We talked a little bit about libraries and tools earlier, but you can use PyTorch or scikit-learn or TensorFlow. All of these have the libraries to convert them into an ONNX model. To do that, you can take existing models that are in different formats and convert them with using things like Keras to ONNX. So you can take your model.h5 file, and then you can use the convert.ONNX to ONNX library to get your ONNX model out. Same with PyTorch, but you can also just export directly from PyTorch as well to an ONNX model. So you can convert an existing model, or you can train and export to ONNX. And then when it comes to using it, It's pretty simple. So you import the library for ONNX runtime. You create an inference session, you run the session, you send in your input data, and you get an inference result. And you can see the example of what it is for Python and C#, that the syntax and everything is actually very, very similar and super easy. I think the hardest part is getting used to the data manipulation in multiple languages. Like Python is really, I think it's so powerful when it comes to data processing and manipulation and all of that, where some of the other languages I think are still kind of catching up there. So when it comes to cross-platform multi-language, like we talked about, this is, if you go to the onnex.runtime or onnexruntime.ai site, this is a graphic that you'll see right on the main site, and you can see that all the platforms that are supported, the APIs, the architectures, and you can click on them, and it's actually interactive. So it'll show you the installation instructions for your preferred like platform language, etc. And we are going to look at one of our demos is going to be with Xamarin, which is coming, the support for that is coming soon. You can use it with Android, you can use it with iOS, but Xamarin is still coming. So that's hopefully going to be ready by the end of this year. So I'm going to show you some dev packages. So let's hope everything works, right? Knock on wood. So then I know we talked about like how there's those pre-built models and there's model zoos. So ONNX has a model zoo that has different pre-built models that you can go use, which we're going to be using one of those with our example we're going to be using the fast RCNN one. So if you go to this, and this is just GitHub ONNX /models, you can see. You can go in here and there are models for all kinds of stuff. That's the other thing now that I think is really interesting. When you go to start building a machine learning model, you don't always have to start at scratch. And in fact, normally you almost don't. Like there's tools out there you can use, like we're talking about Model Builder, or what's some of the other ones? Oh, Azure Machine Learning has AutoML and the designer. So there's like all these tools that you can do for building models, but then there's also pre-built models that you can just grab and use, and they're all made available here. These are with the ONNX format. And then if you click into some of these, they even have like sample code for how to use them. Well, this one doesn't. Of course, I clicked one, but a lot of them have sample code to do inferencing with them. Is this one? Okay, well, I'm not clicking on the good ones, I guess. But there is sample code in here.
But I think something that you mentioned that's actually really important here is the inferencing is actually the easy part. The hard part, and I think some of these examples show it, is like how do you pre-process and post-process the data. And I think that's what a lot of these samples show you. But in terms of the inferencing, it was that, pretty much that one line of code that you showed in one of the previous slides, right?
Exactly. Yeah, the inferencing is actually one line of code when you get to it. So you have the model zoo where you can go and grab pre-built models. We're going to be using one for object segmentation, which is the fast RCNN, which is a type of convolutional neural network, which convolutional neural networks are kind of the go-to for computer vision models. And then there's different architectures within them. All right. So now let's go into the good stuff, the demo. I'm over the boring slides, but I've got a level set and make sure we all know what everything is before we get into it. All right. Oops. Let me just get this ready. Okay, any questions on that side? I guess I haven't checked the chat at all.
I think there might be a question that you're probably going to get to, which comes from Fuel Snowbell, talking about tensors and how they're multidimensional arrays. So just asking about how you multiply them and how that affects the dimensions and things like that. But yeah, go for it.
Yeah, no, that's a really good question. And if you go into this learning path, so this is the PyTorch fundamentals learning path. And the first thing we talk about are what are tensors, because I think that's kind of the, learning the new data type is kind of the hard part, and learning the shape of tensors and how you change them. And so what you actually go in within this section, it's going to talk about NumPy, which is a popular way of manipulating and working with tensors. And then within here, there are different operations on tensors. So you're asking about multiplying and working with tensors. Within here, it shows you different ways to concatenate them, to stack them. There are, so I would say that if you want to learn how to work with tensors, this is like the best introduction right here. And to go through this, and then also this is an interactive notebook, so you can run these cells. So if you go and you sign in to Microsoft Learn and you come here, you can actually run through this and you can edit things. And there's even IntelliSense, so these are the Jupyter notebooks that we use in Microsoft Learn, that we use in Visual Studio Code. And I'm assuming that this implementation of Notebook is probably also the same as the Visual Studio, but I don't know because I didn't have any involvement there. But so you're going to have a really consistent experience with when you to get used to this tool from here to there. So those are tensors. If you come back to the learning path. So again, as I was saying, that there is like the introduction to PyTorch and how this is like all of your basics that you need to get started before you jump into the individual domains. And these ones are specific to, well, these ones use computer vision in their examples, but it goes over and focuses on the concept. So for data sets and data loaders, when you get started, you need data, right? And you need to be able to load data. So if I zoom in here a little bit, you can see that from the torch utils.data, which I showed you when we were looking at the PyTorch documentation, I'm importing data set. And then I'm also importing the, because I can write on here, it can be even fancier, right? I'm importing data sets. And the data sets, this is going to let me import the pre-built data set, or not the pre-built, but the open source data sets that I can use to get started. And then I also have transforms. So I'm going to use a 2-tensor transform to get my images and transform them into tensors. And then I can also do different things like resizing and all of that good stuff. And then, so then to get my actual data from PyTorch, this is the fashion MNIST data set, which is a data set that has about 9 different classes of like shoes and clothes. And they're black and white images that are kind of like a good kind of first hello world. There's also like the digits MNIST, which is another kind of hello world for computer vision. And then you just pass in the transform that you want, and you're going to get back your training data and your test data. I'm not very good at drawing on this, but I probably should.
Random question, Cassie.
Yeah.
Do you know, because here it looks like that Torch Utils data package provides you with these data sets. Do you know if these data sets are actually part of the PyTorch package, or if the utils basically just goes out and downloads it from some blob?
That's exactly it. It downloads it from a blob. And if you go into the source for, so the data sets are actually coming from this torch.vision.datasets. This is creating my data set that I'm going to use to train. This is getting my data set from those open source. And you can go into there, since PyTorch is all open source, you can actually go into their code and you can see exactly the blobs that they're downloading from. And they're listed on different, like I've seen them on like AWS, and I've seen like the Google Cloud and Azure, like they're different blob storage locations essentially that they're just downloading them from. And it's a wrapper around that. So you can just do datasets dot whatever data set you want. And if I go into the PyTorch documentation, actually, I want to go into Vision. And so here are all the data sets right here that you can use. So you can go in here and say, well, like, what one do I want to use? And then you can go directly to the source and see where they're getting their data.
Yep. Yeah, I mean, the reason for the question was, I would imagine that putting all this in PyPy, or however you pronounce that, the package index or repository would get very large, very fast, the size of that package.
Oh, yeah, it would. No, it definitely is just a wrapper to different open source data sets. And I don't know what I think there might even be like legal side that I'm not really, I can't speak to it exactly, but maybe pulling from the source, because I don't like what the license is on that data. Pulling from the source may be okay, but like hosting it yourself may not be okay. Yeah. So I think there's also like a legal side to pulling from the source as well as a functional, because you don't want to include all that.
Right. Yep. Makes sense. Yeah. Sorry for the sidetrack there.
No, that's awesome. I will try to answer everything I can. I will warn you, I don't know everything, but nobody does. And if they think they do, then they don't know as much as they think that they do. Right?
Well, so far I'm learning a lot. So
Fantastic. Love to hear that. Okay. So that was the data sets and data loaders. Okay, so we're still in there a little bit. Let me grab some water. So you'll notice we have both training data and test data, because as we talked about earlier with overfitting, you need test data for two different reasons. You need it for validation, so to validate for each epoch, which I'll show you in a minute, but to see how it's doing after each training layer, to see how well it's training and what the accuracy is and what the loss is. But then also when you're done with it, you need additional training data to see what the end result is doing. So you have your validation data, which validates how it's training after each epoch. And then you have your training or your test data that you would use after. Now, this one's using test data as validation. In my brain, I say validation for validation data, test data for after you train the model and you're testing it out. So these are the different classes. And so this is just a label map dictionary created in Python to then get our results. This is what this image data set looks like. So those are our classes and our images. And let's see here. So the other thing that this goes over is how to create a custom data set. So most of the time when you're building models, you're most likely not going to be probably using the open source ones unless you're doing kind of like some testing out some ideas or learning or that kind of stuff. Like you're probably going to be using your own data. So this shows you how to create a data set. And this is how you do inheritance in Python. So you're inheriting from that data set. You are then getting the item and creating the object and returning back the data set that you can use. This will break down, again, in here, what's happening if you jump into that. And then from there, when you want to actually use your data, you're going to create a data loader. Okay, so what a data loader is going to do is it's going to take my data set. I'm going to tell it how many batches I want. And then there's other different functions I can do, like shuffle, or I'd have to look at the documentation to know all. I don't have them memorized by any means. But then I'm going to create that data loader, and that's what I'm going to iterate through those batches to actually train my model. So with PyTorch, understanding creating a data set and using a data loader to then train your model is an important concept. Okay. So let's go back here. So that's data loaders and data sets. Then there is transforms, which we've talked a little bit about when I was kind of telling you about the, like you have Torch audio and you have Torch vision and Torch text, and those are going to give us the different transforms or different ways to manipulate our data to turn them into tensors, into the right shape tensors, and to process through our algorithm. So in this one, there's a lambda to pads. The other thing is like you want the shape of or the size of your tensor to be the same. So if you have images in different sizes, you can resize them to the same. And then you can also do padding to make sure that the tensors are the same size. So that's what this particular example is doing. I'm going to skip over that. And then for the optimization loop and the running and saving, I'm actually going to go into my Jupyter notebooks and we're going to run through a model there. My Visual Studio Code Jupyter notebooks. So let's talk first now about the tooling a little bit. So one of the things when I first started switching from C# to Python was understanding how to manage Python packages and Python environments. And so Anaconda is a tool that I absolutely love, and I have mine added to my Windows terminal, so that I can just open up Windows Terminal, and now I'm in Anaconda Prompt, which has different configured packages that I want to use for different machine learning libraries. So if I do conda end list, so conda is the CLI for Anaconda, and it's going to show me the different environments that I already have installed to use. And I want to use the PyTorch one since we're going to be using PyTorch. So I'm going to do conda activate PyTorch. And then you'll notice that instead of my base environment, I'm now in a PyTorch environment. So this is going to control the different packages that I'm using and I need to build my model. If I want to know what packages are in there, I can just do conda list. And then that's going to list out everything I have installed in that environment. I can create new packages. And if you don't like CLIs, there is also a UI that you can use to build things out here. But this, I think, if you're getting into Python, just download Anaconda now. If you want to do Python and you want to manage packages, it is the way to go. Okay, So then if I wanted to go to my directory where I have some notebooks, I'm going to do that. And then to activate Jupyter Notebooks, Jupyter is the activation word. It's installed because I'm using Anaconda. And this is going to open up Jupyter Notebooks locally in my browser, start my server, and it's going to actually have the environment already selected that I had in my terminal. And I'm going to jump into this notebook. So I'm not going to actually like run it here. I'm going to go to VS Code Notebooks because I like them more. But I wanted to just show you what like vanilla Jupyter Notebooks look like. And if you were using like Anaconda and the CLI and that kind of stuff, that's how you would go. That's kind of your a common like data science workflow. And then I would have my notebook here. But what's way better than that is this, which I already have open. So this is Jupyter Notebooks in VS Code. It gives me so much tooling like IntelliSense, and I can hover and I can get all kinds of good information. And then I also, you'll notice here, maybe you're using a model that needs a large GPU. Like for example, this is a machine on the cloud that has a V100. I don't have V100 on Tesla V100 on my machine. So what I'm able to do through what's called the Azure Machine Learning Extension is I'm able to use a cloud compute while running this locally in Visual Studio. And so actually VS Code. So you can see that's the name of my machine, or I'm sorry, of my workspace. So in Azure Machine Learning, you have a workspace. And you can see that my Jupyter server is remote. So that's how I can tell that I'm running in it. And if I go over to my Azure Machine Learning workspace, this is my compute right here. And so I can also get into the terminal here if I need to manage different packages for my different environments within it, just like I was running my terminal locally. This already has Conda installed and prepared and ready. So you could go in here, and it also has pre-configured environments for you. So I can do Conda and list here. And I can see that I have a TensorFlow and a PyTorch, and it also is going to have like all the Azure ML packages that I need as well. So this is my preferred way of doing it since I use Azure and I like to have a more powerful GPU for running large models. This is a really nice way to do it. Like you also can use these notebooks directly in this web portal. So that the same notebook experience that you see in VS Code, I'm assuming Visual Studio, but I haven't used those yet, and Learn also are within here. So it creates a nice consistency. Let's see if I have any notebooks in here that I can just open just to show you.
Yeah, and I'll point out that because this is running Anaconda and has all the environments, you can install the sort of the Jupyter Notebook experience for .NET inside of your compute instance here in Azure Machine Learning. So if you want to do this Jupyter-like experience with .NET, you can just install the package, the global tool on here. Because you do have full access to this compute, right? It's just a VM in the cloud for you. So you can install whatever additional packages you need.
Yeah, exactly. It's completely configurable to what you need. And you can use whatever tool you want to use. And then I think if you click in, you can see the specs on the machine. So this has 4 NVIDIA Tesla V100s on it. So that is what I'm using. Now let's go back to my actual Jupyter notebook here. And so this is the quick start from the learning module that I was showing you. So I was going through each individual step, but if you go to, and it's the same actually on the PyTorch .org, the Learn the Basics, it's the same content. You have the quick start here, or you have those individual ones, and you can actually click to go run it right in Microsoft Learn from here, which is pretty cool. So this is what we're going to be going over. If you want to download this or run it in Microsoft Learn later, we'll give you the link, but it's in that. Actually, I'll put this in the chat for you to share. aka.ms/learn PyTorch. So they'll copy that over for you. How am I doing on time? How much time do I have left? Do I have 8 minutes?
Yeah, we have about 8. Yeah, 8 to 10.
Oh my goodness, I haven't gotten there. Okay. I'm going to go really quickly over this because I want to show the Xamarin demo. So we've talked a little about PyTorch. Let's go to ONNX. So in in this particular one, so this is that same example I was showing you step by step. So you already saw the data loaders, and I was going to run this, but since we're short on time, I'm going to go quick. I'm grabbing my device. So again, this is Torch is going to check to see if I have a GPU available. And if it does, it's going to print that it's a CUDA device. Well, it's looking for CUDA specifically. So to create my neural network, this is my neural network class. I am inheriting from the neural network module class in PyTorch. And then from there, this is me building my neural network. So this is the different layers that I'm putting together. I'm using a ReLU activation and then a linear stack. And I'm calling this class and putting it to device. And here's my model. Okay, so when you talk about different model architectures, this is what that looks like. This is the model architecture for this particular one. And when you go into then training this model, you have your loss function, which is how bad is this model? And then you have your optimizer, which is how fast is it learning? Okay, so this is fun. I did this earlier today. I was putting this in. That is Copilot. And then the other thing that's cool about this, look, if this is, it knows what it is. It's my training loop. So when you go to write comments, when you have Copilot installed, apparently it will write comments for you too, which is pretty awesome.
That's really cool.
Isn't it insane? So I was going through and I was adding these comments in, and I was like, okay, I guess it's just going to write it for me.
Nice.
I'm done. Yeah, it is a really neat, and it works in, that's the other thing. I'm using Jupyter Notebooks and VS Code, and my Copilot is working for me, where there's just so much tooling that you get when you use them within this. Okay, so we talked about this. How bad is my model? How fast is my model learning? So the higher the learning rate, the faster it learns. And I could go in for a lot longer than that, but we don't have time. So I'm going to go to the training loop here. So one thing that's specific to PyTorch is you put your model in training mode and evaluation mode. So we need to tell our model that we want to train it. And then we are going to enumerate over our data loader. So remember we talked about our data loader and how it was going to batch through our data. This is why we use that and why it gives us those additional features for how it's going to use and process our data, including if you're doing tokenization for natural language processing, things like that, you can do that within the data loader setup. So it's a really, really handy class and tool within PyTorch. I'm going to get a prediction, and then I'm going to see how well I did. So this is why this is I'm going to quote Seth here because he calls it how the sucky function, how bad is it, the model performing. I think it's a good way to remember that. So you have your prediction and the actual and the loss function, and that's how we get our loss.
And the goal is to not make it suck, right? Make it good.
Exactly. We want our model to perform well. So when you call this, and then this is our validation. So this is now where we'd set our epochs, which I talked about a little bit earlier. Those are the number of layers we want to have training, and that's the number of times it's going to go through our data set. And we can then give it our train function. And so what gets printed out here is the loss at each as it goes through and loops through the whole data set. And once it gets through one loop or one pass, it prints out what the accuracy is and what the average loss is with that validation data. So it's important to make sure that your validation data is different than the data that you're testing with, because things like overfitting you won't be able to find, or if it's not performing well, it'll look like it's doing really, really well when it's not. So make sure you have separate data for validation and test. So this kind of shows me as it goes through each epoch, how it's performing until the end. And I think I can click this and it'll open it. Yeah. So this is cool. You can see how it was performing, the loss at each layer as it looped through each batch. And you can see the batch sizes here. So that is training the model. And when it comes to exporting it, so Torch has ONNX built in, and we can export it like this. So we're giving it our model. We're giving a sample size of a data. So this is just creating a tensor and sending it to the device to do that. So basically when it's sending it to the device, it's either, it's like if you want it on CPU or GPU and you need them to be on the same device when it's going through training. So then we're giving the model a name, and then we are seeing the inputs and outputs And from there, we're able to run our inference. Now, I ran this earlier, so it might still, yeah, cool. We can still run this part because this part's pretty quick. So I'm just importing ONNX runtime. And then I am able to get the session, run it, give it my input, and then it's going to give me its prediction. I'm going to get my classes back, and then this is the prediction. So the predicted versus the actual. Now, the one thing I was going to show you, which we didn't even get to, but this is the soon-to-be released Xamarin report or support for ONNX runtime. And I'll try to get it running. It takes a little while to start up, and hopefully it works.
It just means we're going to have you back on.
Yeah, I mean, because we could talk a whole lot more. I feel like I kind of focused like on the PyTorch side, and then I was going to get to the ONNX, so we kind of cut short because it would be really cool to just show, I think, like all the different languages and stuff of inferencing with ONNX.
Maybe we can just call this one part 1, Luis, and then we'll have part 2 in a couple weeks.
Yep, we got to leave this on a cliffhanger though. So like, as soon as the app is booting up, we just got to cut off the stream.
Yeah, we'll put that over there because you can actually see. And if we go into the logic here, so this is how C# and ONNX runtime. Let me make that a little bit bigger. That's probably a little bit better. So this is where you're creating. So your named ONNX value. You're going to have. So this image has already been pre-processed, and we're sending this in our input in, and it's going to give it back our input that we're going to be able to put through our inferencing with ONNX runtime. So just like you saw in the other examples, like here's our session. There's different optimizations. So ONNX runtime can really improve performance for your inferencing. And one of the ways that it does that is through different graph optimizations. So you can set the level of graph optimizations that you want. And there's more details. I was going to go into the docs on what those different optimizations do. So then when you go to actually train, this one has some specific stuff for the Xamarin platform. So that's not specific to if you're just going to use it in C#, but that is for this particular one. We're going to create the inference session with our model. And then we're just going to get our results here. When we run, we're going to send in our inputs. This is going to have multiple inputs because there's multiple images. And what comes out... Oh, wait, you have to come back next week to find out. I can run it. It takes a little while to run because the Android emulator is somewhat slow. It's a lot faster on an actual phone. So we can kind of wrap while this runs if you need, since we're a minute over.
Yeah, it's fine if we go just a little bit over, I'm sure.
Okay.
Yeah, it's fine. I mean, we might get cut off, but folks can watch the recording if, at a later time.
Awesome. But yeah, so this is doing image processing with Skia Sharp. So again, we were talking about earlier about that processing, which can be hard. So Skia Sharp is specifically for Xamarin image processing, and it's how we're getting the data ready to be processed or inferenced with ONNX.
Yeah, and I think one of the things that I'll sort of call out previously when we're going over the network architecture, right? We mentioned dropout at the beginning. So as you're building those layers, I don't remember if that particular network had dropout, but that's where you would include the dropout layer.
Mm-hmm. Let's see. Oh, it's not letting me. Oh, I know why it won't let me. Okay. There we go. So it's kind of small, but you can see now this is a sample image using that convolutional neural network, the fast RCNN. It sent in this image. It turned it into a tensor. ONNX runtime did the inferencing, and then it returned back the bounding boxes and the results with the confidence score with each one. So that's ONNX runtime with Xamarin.
Very cool. Yeah, I know a lot of folks on the ML.NET side, and some models you can use Xamarin with, I believe now, with ML.NET. But ONNX, you still have a few, there's still a few limitations there. So this is really cool that you're able to run ONNX models using .NET inside of a mobile Xamarin application.
Yeah, I mean, you still have size limitations because the model is on device. And so unless you're going to be making a call out, this particular example, it's running on device. So if you it depends on how you want to architect your product. But if you want on-device models, which there's a lot of benefits to that, can only be so big, right? So there's the size limitation of particular models when you're thinking about deploying and doing on-device inferencing. A really cool thing is actually IntelliCode in Visual Studio 2022 is using ONNX runtime to inference on your device. So that optimization, that speed and on-device inference is happening with ONNX runtime, which I think is pretty cool.
Yeah, it's very cool. And does this Xamarin support also, maybe it does, bring support for things like CoreML and the other sort of on-device hardware acceleration and some of the benefits that you might get with the individual platforms, or no?
I think so. I'm not Xamarin developer.
Okay.
So
yep.
I don't know the details of like the Xamarin architecture and how they work. Like I really focused on like enterprise web development when I was doing that. And then now with AI, there's not a lot of mobile development.
Gotcha.
So yeah, sorry about that.
No worries. Yeah. I mean, I myself, I'm not too familiar with Xamarin. I mean, I could go through the, sort of the tutorial quick start, and then that's the extent of my knowledge with Xamarin.
Yeah, I mean, it's nice too, like when you go in and you create a Xamarin project, like it creates like all this scaffolding for you, like all the projects that you need, like the forms and the Android and the iOS stuff. And then you have your class, and then you put all your, your business logic here, and then your UI and the forms, and then your like specific iOS. So like I know like the basics of the architecture in order to use it, but
yeah,
never deployed a
for
sure.
iOS
app.
Yeah, no, this has been really, really awesome. Really glad we got to see it all working with Xamarin and different types of applications that you might have there. You have already, a lot of folks are already asking. They want another session, so I guess you just gotta come back on.
Thanks. I'm glad you found it useful. I try to like make it accessible, but still kind of get into the weeds. So I'm glad that it was good and that you helpful, and I hope you build cool stuff. And you can follow me on Twitter, and my DMs are open, so always feel free to ask questions. And I really love like when the C# devs start coming to the AI world, because I'm like, yes, let's take it over. Let's at that time.
Yeah, there's a lot of really exciting things happening in that space. So yeah, there's definitely a lot of room for collaboration and continued.
Absolutely.
Carly was just asking if they have any questions, if they can ask you about machine learning or deep learning, and I think you mentioned your Twitter. They can reach you there.
That's like I'm the most right there, Cassie, Breviu, and I'm probably the most active there. Like LinkedIn, sometimes I try to get into it too, but there's a lot of a lot of ads in LinkedIn through DMs on, so it's better to just go straight to Twitter.
Yeah,
makes sense. Runtime, like tag us, like if you're building it and you have questions, like you can always the ONNX runtime Twitter handle as well as a good resource, and that has multiple people on my team that manage it. So that's another good way to get answers if it's specific to like ONNX runtime. But I mean, it could be machine learning questions too. That's
awesome. Perfect. Yeah, I think there was another question. Are there any resources that you would recommend? Fuel here was asking to go deeper into like more of the math and like the reasoning behind a lot of these deep learning models, tensors, and things like that. Are there any resources you would recommend for that?
So if you want to get into the theory, I'd say go for more of like a Coursera class. There's a really good one by, I think his name Andrew Ning, I think is how you say it. Very famous in the machine learning world. But I would say if you want the theory, so there's like kind of two ways to do machine learning. There's applied, where you know how to use the packages and you know how to build the models and you know what they do and a way to use them. And then there's like, if you go into the theory and you want to know the math behind and all of that, you can. You don't necessarily have to, but if you want to, you can. In my opinion, there are people that will disagree with me on that, but I think I built models and I'm more of an applied. So if you want to get into the math side, I've watched some Coursera classes on that. I don't know that like a lot of the tutorials, they'll touch on it, but they're not really going to go into it because it's more about like getting you from point A to point B in like a specific way. So if you're one of those people that really like to know the details of that, I wish I could remember what that course was called. I think it might just be like Stanford's like intro to machine learning that I watched a really long time ago.
While you're maybe pulling that up, Cassie, there's something that I missed in the very beginning, which is there is a hackathon for ML .NET coming up next month. We're planning for the 12th, so that's right after .NET Conf. So if you don't get enough .NET with .NET 6 and .NET Conf, you can come join us and join us for the hackathon. So stay tuned for that. We're gonna provide more details in the next few weeks.
So this is the machine learning course here. And I think Coursera used to have a free month. So when I did this, I think I signed up for the free month and then I canceled. So I don't, but you can, I think you can still get a free month. This is the instructor. It's really good when it goes into the behind the like how things are actually working. And yeah, there might be free stuff on YouTube now too. Like this, like it was a while ago when I started here, because the hardest part is like, where do you start? And when like 5 years ago, there wasn't nearly the content that's out there now. And so I was like, how do I learn it? I'm going to go read this thing. Right. And so this one was really good, but for the applied, there's actually one called like applied ML. I think it's also Coursera, and that one really brought me forward in how to actually, yes, this one. Oh no, this is a different one, I think, because that was not the teacher, but it was, maybe it changed. Maybe the teacher changed. Honestly, it was a while ago. But this one is like, okay, we're not going to talk about the theory. We're going to talk about how do you apply the functions? How do you use the libraries? And like, how do you use Python and the tools that you need? So it really depends on, and you can start there. And like that, I prefer to like start high level and like break things down. Some people like to start on theory and then build up. So we really have to do the way that you prefer to learn. But yeah, so depending on where you want to start, those are good. If you want more like in depth versus our PyTorch learning path, I think is like an hour and a half per module. They're very detailed, and there is actually, they do go into some of the math, but it's not going to be like doing a machine learning class.
And I believe you also helped author, along with a few other folks, the ML curriculum, right? Where it takes you step by step through a series of exercises in common machine learning scenarios.
Yeah, so that is the classical machine learning. So that's focusing on scikit-learn, which is where I started. And I honestly think it's a really good place to start too, because it's just easier to use. I think their documentation is pretty good. Wait, that's not right. Is this? No, that's not right. Where is it? I will have to get you that link because, oh wait, I bet if I put Microsoft in here, it'll come up because I think it's under our GitHub. Yeah, there it is. ML for beginners. That is a really good call out. So this is really nice. It has lectures and classes, and it has examples, and it has assignments. There's really nice graphics as well. Like if you're like a visual learner and you really like seeing things created, there's a lot of like info sketches, or those like what are those called? You know, where they have like the images in the sketch.
Oh yes. I know which one you're talking. They're not zines, are they? I know I've heard them called something like that. But yes, like, yeah.
So yeah, this is a good one. It also talks about the history. It talks about these things. I love these things. I don't know what they're called, but there's like really good visuals in it as well that Tomomi made. She's super talented, and so so that's another good one if you want to start with classical machine learning. That one's free, obviously, free resource. I mean, like, there's so many good free resources out there. It's just kind of hard to like find. And I also think what helps me is having a goal. So something that you actually want to build, because when you kind of go into a space, there's all these things happening and you don't really know which one to focus on. And there's a lot of new terminology. So that's why I really like that you start with terminology in the beginning, because like, I think every field within tech, like half of it is like jargon and like learning what all of those things mean. And so yeah, that can be a little bit overwhelming. So I think the PyTorch one is great. Like if you already know how to like program, and I think some familiarity with Python, you kind of need a little bit of familiar with it, then that's really great. Even though I think Python's so simple, you can kind of look at it and just understand, like Python is such a simple to use language. And then if you want to get into more of the classical side, like scikit-learn, that's what this one would be good for too. And then theory, I would still go to like a Coursera. I don't know what other, are there other good like online learning platforms for like more detailed courses? Like, I think there's been more that have come out since then.
Yeah, I mean, I know some folks might use, and those, well, I guess technically Coursera is paid now, but you also have Udemy, right? There's a few
Yes.
really good courses there.
Yes.
Yeah, so there's a ton, and it really, yeah, I think the moral here, or the message is, there's tons of really great resources, which actually makes it hard, right? Because it's like, which one do I start with? So I really like what you mentioned there about having a goal in mind. So maybe some of these courses might have like, I don't know, train a computer vision model, right? And that's your goal. And maybe you might not know everything, and that there is to learn about deep learning and machine learning, but you now know this one thing and how to do this one thing, right?
And that's how it starts, right? And I think it's also something I've heard from a lot of people is they're like, oh, well, I can't just quit my job and go learn this. And what I did, I didn't quit my job and just go learn this. I made it part of my job. Like I just came up with ideas of models that I thought would be useful. And I worked actually at a law firm at the time. I was an in-house developer at a law firm. And they were supportive. I was like, hey, can I spend 2 weeks? I want to try to figure this out. And they were like, that's cool. And they let me do it. And so like, I know not all cultures are like that. I was very grateful to be in a culture where they would give me like a sprint to try things out. But a lot of companies have hackathons and things like that. Like take that time to just try to build something. And I'm definitely one of those people that like learns by doing. And so that was kind of how I got started. I didn't like quit my job and go to school I don't have a machine learning degree or anything like that. Like it's just about having a goal and like not quitting until it's done. That's the other thing is what I've noticed most is people start and then they quit. They'll spend because the thing is it is going to be hard and you do have to work at it. And it just like it was when you first started programming, but a lot of us have been programming so long we forgot that it was hard when we first started. And so it's just like that, like with anything new.
Yeah, no, And so, yeah, I mean, I think, those are all really great resources and really, really awesome advice. We went over, but I know that folks are still in the chat and they're still just, really enjoying the stream and all the resources that you're sharing, which means that we'll have to have you back at some point, if time permitting, if you're not too busy building, cool stuff with ONNX and PyTorch. And yeah, we just really want to thank you for joining us and just, helping us learn and helping folks learn a little bit more about these packages and these tools and how it might be useful for them. Awesome. Any last sort of parting thoughts?
No, but I am working on some content that I think you might like that I'm not going to tell you what it is. I'm going to keep it mysterious. But I do think it would be one that would probably be interesting to this audience. So
awesome. Well, stay tuned. And we're definitely looking forward to it. Thanks a lot, Cassie. And thank you folks for joining. We'll see you next time. Take care.
Bye.